Yeah, because like once we substituted t in for x cubed, we still had one variable that was in terms of x.
Yeah, but even if you do that, where's the dx go?
Whoa, whoa, whoa. What are you talking about now, Don? Now you're confusing me. Okay, so then you would say, now I'm just confused.
Bring the 3 over.
Yeah, okay, so you have this, but this doesn't have a 3 in front of it. You notice that? So if you multiply this by 1/3, so 1/3 dt actually equals x squared dx. So you can substitute this 1/3 dt into this, and then you can substitute t in for these x cubed.
Oh, no, you can't.
Because
okay,
the whole
yeah,
point of the
yeah.
problem is that we're taking the antiderivative.
Oh, so maybe that's where this problem should have started.
Yeah.
I never understood that from line 1. Isn't the problem you're trying to find the antiderivative?
Oh yeah, my bad. I forgot to write the x here.
Oh, and you forgot to put the integral sign.
There you go.
So little
the
f
whole
of
point-
x is the antiderivative of 1 over x to the...
What?
Yeah.
Just get rid of
Big.
We're trying to find this. When I was copying the problem down from the paper, for some reason, I just wrote down f of x equals 1 over x to the 7th minus x. This is what we're trying to get. The integral of this. Okay? Everyone with me?
Gotcha.
That's like that's what they originally said. They said that we were taking the antiderivative of that, but what we're gonna do that was we're gonna say that the inside was f of x, so that we could solve and get it in terms of t, so we could then plug it back into the antiderivative. And so that's why he was getting a little confused, because we were still, because the way we did it in the general write-up was we did f of x equals that, and we solved for t. And now we're just here, we're just plugging it in for the antiderivative.
We on the same page now? She knows what's going on. I keep looking at her. She knows.
Z knows everything.
Okay,
Is everyone
so
confused? Like, can we clarify?
No, no,
We're good.
yeah,
We're good.
okay, so to get rid of this x squared dx, then we found that 1/3 dt is equal to x squared dx. So now we can just rewrite the problem as 1 over t times t plus 1 t minus 1 times 1/3 dt.
Is that a minus in there?
Oh, where?
In between that t and the 1? Oh, that was wondering.
Okay. No, you wanna go?
Yeah, sure. What we're doing now is basically what we did in part 1. We're just doing the same process of separating these guys as we did in part 1. So you guys knew what went on there, right? And we got our constants, we got our, are they written down? No, we got our a. Oh yeah, we have our a here is equal to -1. We have our b is equal to 1/2. And we have our c is equal to 1/2. Right? And so I'm going to be walking back and forth here a bit. And so when we are going to take the antiderivative of this guy, is it t plus or minus 1?
Plus
All
1.
Yeah, there we go. We can decompose it just like we did there.
We don't have to go through the process because we already did it here. It's from part A. Do you see how that kind of goes into each other like that?
Alright, cool. So then, we know when we take the antiderivative, we got a constant, like that 1/3 there. We suck them out in front.
Put dt just because you
And so we've got 1/3 times this now doable antiderivative of a -1 over t plus 1/2 times 1 over t plus 1 plus 1/2 times 1 over t minus 1. What do these guys look like to you? These are things that we've just been doing in class. Because you can really look at, yeah, when we're on the antiderivative step now, what do these guys look like to you? This is a function to a negative first power. What, when you take the derivative of it, will give you 1 over.
You can picture this as like being 1 over x.
So
Do you
much
remember?
rate function.
Yeah.
which, do you remember which function?
Well, 1 over x.
ln.
Bam. LN.
Absolute value of x.
Exactly, absolute value.
Khaled hit it. Khaled pushed it on the spot. So we've got now 1/3. We're taking the antiderivative of this. So what's going to be the antiderivative of this guy? It's going to be a negative of what? Absolute value. There you go. So this is going to be 1/3 times a negative ln absolute value of t. What about the next step? Remember, take the antiderivative. Don't worry about the constants. Just take the antiderivative of this guy. Nope. Treat this guy. This guy is a linear function, just like him. You're gonna treat him just the same.
T plus 1.
There you go. It's gonna be plus this constant times the ln of the absolute value of t plus 1. And I think you guys are getting the idea. So then you're just doing the same thing for this guy. 1/2 times the ln of the absolute value of t minus 1. Cool. 2 steps left. First step, distribute this guy here. So then, oh wait, it's all out again. Alright, I hope I don't lose you guys. I'm going to do 2 steps in one, just for the sake of board space. What's the problem with this guy here? Besides the multiplying through.
It's too big.
It's too big. Okay,
Remember how
that's
he
not
said-
what we're looking for. Think of when we use substitution, the very last step we'd always have to do in class.
Oh, real world.
Put everything back.
Right.
Put everything back. We're substituting in.
That's what she
Remember,
said.
t,
Put it
the
in
original
real
problem was
world.
given us to us.
Oh yeah.
x.
Okay. So we're in T world, as Sandra would say. We're in T world right now, and we need to go back into the real world, back into the X world.
Because our original
Pretend I
problem
look
was
like
given
Sandra
to
right now.
x.
Why, just give me that face, Chris.
So
What?
we are going to have then.
That's how I know.
We're gonna have then a negative ln of the absolute value of x squared or of x cubed divided by 3 plus the ln of the absolute value of x cubed, right?
Plus 1.
Divided by, we're doing 1/3
X cubed plus 1. Because remember,
Thank you.
t's. Yeah.
plus 1. Little guy's fit in there. Multiplying the third times a half, both of the coefficients, divided by 6. And then the last factor here is going to be the ln, the absolute value of x cubed minus 1. And it's divided by 6. Same thing as last guy. Always remember your plus c at the very end, too.
Plus c with also on right.
Yeah. And then, as Sandra said in class today, when you multiply through by 1/3, you multiply in a constant by another constant, it's still going to be constant. Because it's unknown and we don't know the actual value of the constant.
So even if you multiplied it by c.
Yeah, by,
it's the same
it could,
thing.
you can
C
multiply
could
by a
be
billion,
incorrect,
it's still going to be
basically.
C.
So.
And so, this is your final antiderivative for your function 1 over x to the 7 minus x. What?
That's an equal sign.
Wait, don't forget your dx.
dx, yeah. Oh, right.
Final guy right there. So you even got a cool little equal sign. Final guy right there. And what you should be able to do, this is a decomposition, which means that before we took the integral, they all shared something. And it would end up equaling back to this. So what you should be able to do, just something to think on, is once you decompose it, if you go and try to get a common denominator again, you should end up back with this guy. You know what I'm saying? We're breaking them up, and then basically we should be able to put them back into pieces. So just a closing thought once we get into it. Think about that as we're going into calculus. So, questions?
Think about that as you continue with the day.
Let's start.
Good.
No questions? Z, you got a question. I can see it.
No, I don't worry.
Got it all?
Well, it looks like it's
Sure. Yeah.
Okay, so
Done.
these constants, A, B, and C, there's
Done.
numbers.
Questions?
Every function that you take the derivative from using this.
Use this method.
It was set up originally like that, you know.
And